Hi guys, welcome back. Today we're going to start chapter 3 and we are going to start adding expressions together and combine terms, okay? So the first thing, since it's the beginning of a chapter, we're going to review a couple things that you learned last year that will help us in this chapter. So we're going to use these throughout the chapter, so if they're not quite there, that's okay, but we'll get there. So we're going to recall a couple things, like I said. So we have 7 plus 2x, and the first question is how many terms are there? And terms are separated by addition and subtraction signs. So here there are 2 terms because there's 2 chunks of information. We have the 7 and the 2x. Okay, so that was one thing that we learned last year. Second thing we learned last year is evaluating an expression. So if you have 2a minus 3, and we know that a is 5, instead of writing a here, we're going to write 5, and we're going to write that in parentheses. Okay, and this would then be solved by doing what we normally do with PEMDAS, right? So we'd multiply first, so 2 times 5 is 10 minus 2, and then 10 minus 2 would be 8. So I evaluated that expression by plugging in 5 for a. Okay, you guys talked about combining like terms last year a little bit. So like terms like x's go with x's, y's go with y's, and numbers go with numbers. And we actually call 6 and 9 here, we call them constants, okay, because they're never changing. They stay 6 and they stay 9, okay, and they're not being multiplied by a variable. So this would be 4x because there's no like terms with 4, but 6 and 9 can be combined to be 15. So this would simplify to 4x plus 15. Now this can't be combined any further because there's no like terms. I have x's, I have y's, I have 3, okay, so I would just have 4x plus 2y plus 3, okay. All right, you talked a little bit about expanding algebraic expressions last year. So we're going to go over this again later on in this chapter. So if it doesn't click, that's okay. It's just kind of be like, oh yeah, that's in the back of my head. So remember, we can distribute this in. So we would do 3 times p, which is 3p, and 3 times 2. So I did 3 times 2, which is 6. So that would be plus 6. So that's expanding, and we're making it bigger in a sense. Okay. We also call that distributing, okay? So a lot of times we don't use the word expand, we'll use the word distribute. Now factoring is undoing the expanding. So we say what goes into both 2x and 10, and I know that 2 goes into both of them. So then I would divide this by 2, divide this by 2, and 2 divided by 2 is 1, so that would just be x. And then 10 divided by 2 is 5. Again, if we're not super confident with that, that is absolutely fine. We're going to talk about that more later this chapter, okay? All right, now for the good stuff. Now, a lot of times we use this with bar models. I'm not going to teach you with bar models, but if you do need help, I can show you how to use the bar models. And I'm sure some of you are cheering and some of you are sighing, so hopefully you're happy we're not using bar models. So I'm looking here and I see that I have an x and an x. So I have 0.7 x's and 0.3 x's. So what I'm going to do is I'm just going to add the coefficients. So numbers in front of a variable are called coefficients. So 0.7 plus 0.3 is 1. And then I would go ahead and get x, because that's like saying 0.7x plus 0.3, it means 1 whole x. Okay, let's go ahead and try the next one here. So we have 1/2 a plus 1/4 a. Again, I can only combine a's with other a's. So I have 1/2 of an a and 1/4 of an a. So I know I'm going to add these together, and I know that when I'm adding 1/2 plus 1/4, that I need a common denominator, which would be 4 in this case. Well, I need to multiply top and bottom by 2 here to get 2 over 4, and this is already over 4, so we're good there. So this is 3/4. Now, if I just write 3/4 as my answer on that test, I'm going to get that wrong because it's 3/4 a. Okay, because I have to bring that variable down for the ride. So this is like you saying you have 1/2 an apple and 1/4 of an apple, so now you have 3/4 of an apple. Okay, let's try another one. On the next page here. So we have m's. Now, whenever there's not a number in front of a variable, there's an assumed 1 there. So go ahead and try this one. So there's 2 ways I could write it, and I will accept either way. So you could write this as 1 2/3 m, because 1 plus 2/3 is 1 2/3. Or you could go ahead and get a common denominator, so 1 over 1 plus 2 over 3. So our common denominator is 3, so that's going to stay the same. So I'm going to multiply top and bottom by 3 here to get 3 over 3, plus 2 over 3, which would be 5 over 3, So that would be 5 over 3m. So either of these answers would be acceptable. Okay, I'm going to redraw that just because I crossed out the letters. Okay. And again, remember, through any of these videos, you can pause at any time to catch up, okay? All right, go ahead. I want you to try this one now. So I have 1/4 y plus 1/6 y. I'm going to go ahead and get my common denominator of 12. If you use 24, that's absolutely fine. So I'm going to multiply top and bottom by 3 here. So I get 3. Multiply top and bottom here by 2, not 4, sorry. I was thinking I had 24. So that would be 2. So this would become 5/12, and it would be 5/12 y. Okay, not y is at 5/12, it's 5/12 with the variable y. Okay, do we have another one? We do not have another one. So remember, we only combine the same letters with the same letters. Okay, have a wonderful day, and we'll talk to you later. Bye.